Right, in this Revise With Me video, we're going to be looking at trigonometric graphs. This is for higher tier students. As with the other videos, if there's any requests for topics that you'd like to see covered, added to the higher or intermediate tier playlists, then either just go see a maths teacher or contact us via Twitter or just pop in to see Mrs. Lawrence any lesson or any break time, and she can make sure that it's up there within the next couple of days. Right, this topic can be calculator and non-calculator. I'm going to talk about it from a non-calculator perspective so that you've got a good idea of being able to tackle these questions on both papers. The sine graph and the cos graph are quite predictable in shape because they're both a wave graph and they have quite strong properties. For example, the sine graph here, the first one, has a maximum value of 1 and a minimum value of -1. And in a similar way, the cos graph here also has a maximum value of 1 and a minimum value of -1. One way of remembering which of the waves is going to start at 0 and which of the waves is going to start at 1, this wave-like pattern either being starting at 0 or starting at 1, for these pair of graphs is to look at the name of the graph and to see if it has an I in it. I think of the I as looking a little bit like the number 1, and I think of the O as looking at a little bit like the number 0, and I use this to help me decide which way round we're going to draw the graph. So as I'm looking at this top one, and I have sine x, which have what I think of as a 1 in the centre, this tells me that it's going to start at 0. And likewise, or alternatively, with the 0 in the centre, this tells me that this graph is going to start at 1. So they are just two little tips that I use to remember how this graph is drawn. The key features of both of these graphs happen at 90-degree intervals, and by the time you've gone from 0 here to 360, you've done a complete cycle or a complete wave, and then all the features are repeated. So from 0 to 360 covers everything, and then if you wanted to look in more detail, then you would need to be looking to using a calculator to have values that are in between 0 and 90 or in between 90 and 180 and so on. So looking at that first graph, the sine graph, and because I can see the 1 there as I read the word sine, I know this graph is going to start at 0. It takes its maximum value when it gets to 1 when it gets to 90. It's back to 0 when it gets to 180, and it takes its lowest value of -1 at 270. It's back to 0 then at 360. The shape of the graph is a wave. You do have to make sure that you hit that maximum value, and likewise, no matter how squiggly your curve is, you have to make sure you hit the 180, and then you have to make sure you hit that minimum point at 270, and then the next point 0 at 360. This coordinate here, 90 at 1, this coordinate here, 270 at -1, are some really important features that you need to remember. And the fact that it cuts through the axis at 0, 180 and 360 is also quite important. Those features are very, very similar when you're looking at drawing the cos graph. So if I go to draw the cos graph now, seeing that 0 there reminds me that my cos graph starts at 1. This time, when I come to draw the graph, 0 there at 1, cutting through the axis at 90, reaching its minimum value of -1 at 180, back through the axis at 270, and having its maximum value here at 360. This time as I come to draw the graph, I've got to make sure that my drawing skills, no matter how wobbly, go through those key features. If I had the sine or cos graph for a longer interval than 360 degrees, the shape of that graph would be repeated. So this graph would continue to oscillate between 1 and -1 in that same 360 interval, just repeated over and over again. In a similar way, the sine graph would also go from -1 to 1, but would start at 0 and repeat, and so on in a similar fashion. The third trig graph that you need to be able to draw here in question 3 is the tan graph. And the tan graph has slightly different special features. This is not a wave graph. This graph actually has special lines called asymptotes, which are boundary lines that can't be passed. So if you use your calculator and you find the value, or try to find the value, of tan at 90 degrees, it'll tell you it's a mathematical error. That's a value that doesn't exist for tan, and that is repeated then every 180, so it'll happen again at 270, and it'll happen again later on as you repeat the pattern. Now, values for tan equal to 0 is 0, but then as you increase the angle, the tan values increase quite rapidly. This doesn't have a maximum or minimum of 1 and -1. This goes to infinity and minus infinity. And this time the graph simply increases at a rapid rate. If you put tan of 90 into your calculator, it'd give you a mathematical error, but if you put tan of 90.1, it'd give you a very large negative answer. And this graph then approaches 0 at 180, but repeats that very strong pattern between 180 and 270. Likewise, the pattern that you can see here from 90 to 180 is then repeated from 270 to 360, again hitting 0. The tan graph will have that repeat if you have a larger interval than 0 to 360. Question 4, just underneath it. This is the picture of the sine graph drawn for you. This time the focus is on the coordinates of that maximum and minimum point. The maximum point happens, remember, at 90 degrees and has a maximum value of 1. The minimum point happens at 270 degrees and the minimum value is -1. Question 5, this would be the cos graph drawn for you. Here we're looking to see where does it cut through the x-axis, what is its minimum value. It cuts through the x-axis at 90. So at 90 it's with 0 because it's cutting through the axis. 90 degrees later at 180 it's down to its minimum value of -1. Question 6 has a sine graph picture for you, but this time is dealing with the symmetry of the graph. So one solution for x equals -0.5 is 210. -0.5 would be here, going across my graph at minus 0.5, I can actually see an answer here and an answer here. Now this answer would be the 210 answer, and the symmetry, the distance, the symmetrical distance between that cutting point of 180 and that answer of 210 would be repeated and be of the same size here, from that cutting the axis point to my solution. So if that's 180 plus 30 to make 210, this would be 360 take away 30 to make the 330. Question 7. Here's a picture of the cos graph again, and you can see this time that I've got more focus again on the symmetry of the graph. So if I'm looking for cos of 0.5 on my graph paper, I'll draw a line across at 0.5, and I can see, oh, not very good. And I can see that I'm making contact with my graph in two locations. Once here at 60, and once here again at 360. Oh, sorry, 300. So my answers for cos equals 0.5 is it happens at 60, and it happens again at 300. For part B, use your graph to solve cos x equals minus 0.5 for 0 to 360. So minus 0.5 is going to be here this time, and as I go across my graph, I can see that I've got two possible answers. I have a connection point here at 120, and then I've got an intersection point here at 240. So 120 and 240. For the third and final part, we're looking at x equals minus 0.75. So minus 0.75 is going to be here. And as I cut across my graph, I can see that I'm making 2 points of contact here, and then again there. So I can see from the first one, that's going to be 140. Now don't forget about the symmetry that is at work here. So the gap between this 90 and that 140 is a 50-degree gap. The same size gap would be here between the 270. So I know it's 220 because I can see it on my graph paper. But just to emphasize that I could have worked that out anyway. Pardon me. Question 8, our last question in the booklet. This time is a sketch the graph question. Sketch the graph of cos x between 0 and 360, and then we're to part B and part C. So like I said at the start of this little video, I can see a 0 there. This reminds me that I need to start my graph at 1, because I think of them as alternatives. And if it had been a sin x graph, that would have reminded me to start my graph at 0. So I start at 1, 0 at 90, minus 1 at 180, back to 0 for 270, back to 1 for 360. I'm drawing a wave. that wave would continue if I was going to continue the graph past the first interval. One solution of the equation of x equals 0.766 is 40 degrees. So if I decide to just show you 0.766 to be here, that solution would be 40 degrees. And it says where would the next one be? The next one would be just there. If you can see that the gap here between the 40 and the 90 would be a 50 degree gap, I'd have the same size gap on that side between the 270 and the angle that I'm looking for. So between the 40 and the 90 there's a 50 degree gap. Between the 270 and the 320 there's also a 50 degree gap. So that's my 270 plus a 50 degree gap. Part C of the question says use your sketch to work out the value of cos of 200. Well, here's 200. Here's 200 just here. So if I go down, I can see that it's negative. And if I go across, this will only be an estimate, but I estimate it to be minus 0.9. If I work it out on the calculator, it's actually minus 0.94. But this was taken from my graph.